Hey there. Welcome to today's session that is Introduction to Kubernetes. I'm Injira Ramalingappa, DevOps engineer. Okay, so today's session we're gonna learn what is Kubernetes and how it is making deployment so easy and how it is so flexible and how can we make scalability very easy in here and how it is attracting the IT industry so effectively. Okay. Okay, without any further ado, we'll get into it. Okay, today's agenda. Today we have contents like Kubernetes, what is Kubernetes, and the difference between Docker Swarm and Kubernetes, architecture of Kubernetes, and some of the object of Kubernetes that are pods, replica sets, services, namespace, deployments, and rolling update. Okay. So basically, what is Kubernetes? Wherever I go, in cloud computing, in containerization, in deploying an application, why it is so famous? Kubernetes is an open source container orchestration tool. It's a open source container orchestration software. It was originally developed by Google. So, and it was the first, and it was very first released on July 21st, 2015. And it is the ninth most active and attractive repository on GitHub in terms of number of commits. Isn't it interesting? Yes, let's get into it. So, before going to the architecture or more about Kubernetes, let's see the features of Kubernetes. What is the feature? Why it is so famous? Because of these features only, it is so famous. So, first one is replication controller. So, then we have secret management. After that, rolling updates. After storage management and L checks. Finally, resource monitoring. So we see each and every feature in detail in the coming slides. Okay. So why it is so famous compared to other container orchestration tool? Why Kubernetes is so famous? If I take Docker Swarm, here we have in the left side we have Docker Swarm, in the right side we have Kubernetes. So it says easy to install. Docker Swarm is easy to install and initialize, right? We can install Docker Swarm or on our instance uh, just by giving the command sudo docker install sudo hem docker install -y, right? So after that, we can initiate the container orchestration tool just by giving the command docker swarm init initialization. But what happens to Kubernetes? It's very complex. Why? Because which needs 4 GB RAM and 2 CPU core. Okay, it's not like it's impossible to install on our instance, but it takes more memory and more storage space. So and Docker Swarm, it compares to Kubernetes, it's very faster. Obviously, it is very faster because here we are just we have the provision to you know connect the number of nodes which we want. Here also we have that provision, but in if we are creating a cluster, it should have a minimum number of 3 nodes. So that is why it's slightly slower than compared to slower than Docker Swarm, but it has many features than Docker Swarm. So the next feature or difference is not reliable and has less features. But in Kubernetes, we have more reliable and comparatively has more features. Here we can scale up and scale down. Here also we can scale up and scale down, but we can do L checks here. We have namespaces, we have config maps, we have secrets, everything. It has Kubernetes has more features here. So Docker Swarm also we can create replicas and services. Also we can create port mapping. Also we can do. But here in Kubernetes, it has more features compared to Docker Swarm. Okay, so let's dig into more about Kubernetes. What is Kubernetes? So Kubernetes, also known as KS, is an open source system for automating deployment, scaling, So it automates the deployment. It helps in scale up or scale down a number of containers and management of containerized application. So we can manage and control the containerized applications versions. And so basically this is what Kubernetes is. It's just a open source uh, container orchestration tool, and it helps automating deployment, scaling up and scaling down our containers, and and it manages the containerized application. So what is containerization basically? So if we go through the definition here, so containerization is a software deployment process that bundles and applications code with all the files and libraries it needs to run on any infrastructure. Traditionally, to run any application on your computer, you had to install the version that matched your machine's operating system. So, speaking of containerization here, it just we are just bundling up the software. So we are just we are just packaging the libraries and the dependencies which is needed to run our particular application. That is it. So containerization means we are just bundling up the software, we are just packaging the libraries and the dependencies which is needed to run our particular application. That is what containerization means. Okay. And speaking of our Kubernetes architecture, having said that, Kubernetes has more features. So here you can see here in the control plane we have API server, scheduler, control manager, and HCD. And in the worker node we have pods, Docker, Kubernetes, kubeproxy. So we'll see each and every aspect, each and every concept here. What is API server and what is scheduler, what is control manager, and what is HCD. So coming to the API server, if I go with the definition, so it exposes the Kubernetes API. The Kubernetes API is the front end for Kubernetes control plane, and it is used to deploy and execute all the operations in Kubernetes. So API server means it processes the request. Whatever the request given by the user, it processes the request. Okay, it's like a front end of the control plane. It's like a front end of the master node. It's like a gatekeeper. Whatever the request I give, it will first go to API server. It process that request. So here, for example, if I give the request like kubectl create 10 replica of tomcat, this is my request. 10 replica of my create is my request. That request will be processed by the API server. Then uh, rest of the action will be taken care by the other components here. So next here comes scheduler. So whatever the request processed by the API server, this scheduler what it does, it watches the API server, it will schedule the task. So it will schedule the task which is processed by the API server. Okay, so basically scheduler schedules the task on which node the particular task to be accomplished or particular task to be established. If I go with the definition here, the scheduler takes care of scheduling of all the process, dynamic resource management, and manages present and future events on the cluster. Okay, so scheduler what it does, it just schedules the task on which node should I create a replica or should I create a uh, pod, or on which node should I create a container. So scheduler it just schedules the task. Okay, that is the job of the scheduler. And the next we have HCD. HCD is basically a database. So where we are going to, look for the details or the information about our pods, containers, replica sets, or deployments, or about our nodes. So what happens when we give the request, okay, to the API server? So HCD only API server can access the HCD. Okay, because of the security reason, only API server can access the HCD. So if I give the command or request kubectl get pods, so this is my request. I'm asking for the pods information. What it API server does, it access the request, process the request, and it asks for HCD. It communicates with HCD and provides the information about the pod. So if I go with a explanation here, HCD is a highly available distributed key value store, means database, so which is used to store cluster wide secrets. It is only accessible by Kubernetes API server as it has a sensitive information. So whatever the request we give for the information about the pods or any kind of the information we want, we give the request. So request will be accessed by the API server and processed, and it will communicate with the HCD and will give the information about the pods. So that is about HCD. And next we have is control manager. So control manager is a, you know, runs all the controllers on the Kubernetes cluster, although each controller is a separate process. But to reduce the complexity, all the controllers are compiled into a single process. What is does control manager? It is responsible for high availability. So if my one of my container goes down, so one of my container got ruptured, what this container manager will do, it will help for self healing. Okay, this is the main task. High availability, taking care of high availability is the main task of the control manager. And if I come to the worker node here, uh, process of worker node. In worker node, we have Docker, Kubelet, and Kubeproxy. So Kubelet is a agent. It's like an agent. It's a front end of worker node. Whatever the request processed by the API server will communicate with the kubelet. Kubelet gets the image. So if I give the request like uh, get, create 10 replica of Tomcat. Tomcat is my image. What it does, API server communicates with the kubelet. Kubelet process the request from the API server, and it will fetch the image from the Docker Hub. Okay, so this Tomcat image will be fetched by kubelet from Docker Hub. This is the task of the kubelet. Okay, kubelet is like an agent. And we have in the uh, worker node, we have kubeproxy. Kubeproxy means it's like a network rule. It's like a network rules in order to communicate between the containers. If I want to communicate between the containers, or from externally I want to communicate with the container, so it's like a network rule. It helps. Okay, it's like a network rule to communicate between the container. Okay, that is it for today. So thank you for attending.